In part 3, I established these two numbers as triggers to set the high vacuum and the low vacuum. This would essentially be the 25, which I want as the trigger to turn off the motor, to stop pumping air out of the tank, and then a 15 to, if it gets below that threshold, then it starts the motor again. But I'm not really happy of just hard coding these numbers in. I would rather adjust these numbers using a potentiometer or buttons or something of that sort. In this part of the project, I'm going to add two potentiometers, one to adjust the high and one to adjust the low. There's many ways to do this. I could actually add a button to switch between high and low and use one potentiometer, but it's just really easy to use two potentiometers. The two potentiometers would be connected to different channels of the ADC, and they would feed these particular trigger locations. So let's go ahead and put the circuit together for the two potentiometers. To adjust the high and low triggers, I'll be using trimmer pots, trimmer potentiometers. These are just smaller potentiometers, and they're it's less likely they'll move on their own, or by you can only really modify it or change it by using a screwdriver. So it's harder to lose its position. So I'm just going to put them in the breadboard here. And just like we did with the other tutorials with potentiometers, we're going to attach each of the outside leads, one to ground, one to power, or one to 5 volts, and then the other one is going to go directly to one of the ADC pins. So this is one pin going to ground, and the other pin is going to 5 volts for this trimmer, and for this trimmer one is going to ground and the other to 5 volts. And if you can actually switch this around to determine the rotation, if it's going to go if it's going to reduce or increase on the rotation. So if it and you can also do this mathematically, and I'm going to show that to you. Now we can take the middle pin and take it to the ADC. I'm going to take this to pin number 1, and the other trimmer will go to pin number 2. That's not long enough. That's pin number 2. Pin number 0 is the sensor, and pin number 1 is this potentiometer, and pin number 2 is this potentiometer. So we're finished with this part of the circuit. Let's get to programming the different channels of the ADC. The first thing I want to do in this program is to add another label on the LCD, and I'm going to call it H for high and L for low. And this will have 1, 2, 3, 4, at least 5 spaces in between, because the number is going to be at least 4 digits, or it's going to be 4 digits. Where I've hard-coded the two lines here for the triggers, the high trigger and the low trigger, I'm just going to put a couple variables in here, and I haven't declared them yet, but just so I know what I'm intending to do is I'll put I'll call it high trigger and low trigger. Since these are going to come from the ADC, they're going to need to be global variables. We're going to have to, because this is outside of the scope of this, the ADC vector interrupt routine. We have to declare it outside of all of this. So we're going to just add it to the static volatile int, and I'm going to keep it as an int just to make things simple. I probably should be copying and pasting just to make sure that I don't misspell. So I'm going to copy that. And I'm just putting it all into one line. We can, if it's going to be the same declaration for each of these, you can put them all in one line, and they'll all equal 0 at the end. The next thing I'm going to do is add the code that relates to the ADC channels. I'll use the switch statement to determine which channel has been, I've gotten a result. This method has been used in the tutorial of ADC channels. We'll use the switch command, and ADMUX is the register that I'll be testing. For the first case, it will be channel 0. We actually don't know the number yet because this number has to be what would be the ADMUX with considering the setup, this bit being on. So let's take a look at what this number would be. Ref S0 is this particular digit in this register. So we need to know what this number is, so we don't destroy where this 1 is. And since this is in the, whoop, that's not right. Yeah, separating this by 4 bits. This is in the 4th place, so this would be equal to 4. And if I had a 1 here, then this would be 4, 1, which would be the second channel, and 4, 0 would be the first channel, and 4, 2, which this would be equivalent to the third channel. 0x, should have said that before. And this is the hex equivalent. So we can use these numbers in our cases. So let's go ahead and go to case 0, or for the channel 0, it would be 4, 0. And the next case would be 0x41 and 0x42. Each of these have to have a break. Let me have the default in here first. So let's put the breaks in. And this is so it exits out. This will exit out after it's found its test case. Then it will exit out of the switch. Since inside of this case, we're going to have, let me separate these a little bit better. We're going to have the sensor. So we can take this code here. We have the inches of mercury and the formula that we determined to convert it from the ADC to inches of mercury, and sending it to the LCD. We can put that into this case. So only when it's reading or getting the result for that particular channel, it's going to do these 2 functions, or these 2 commands within that particular, the appropriate condition. And now we need to make the ADMUX equal to the 4, 1, so we can have it do that next, do the next channel next. So let's do that. ADMUX is equal to 0x41. So when it gets done with this result in the first channel, it'll make the channel now the second channel, and then it'll go into this portion of the program. Just for now, we're going to make the high trigger. I'm going to copy and paste here. The high trigger is going to be equal to the 10-bit result. So we're just going to show in the beginning the actual raw result of the ADC on the LCD, just to see what our very low and very high values will be, so we can do another formula. Since the ADC number will be somewhere between 0 and 1023, we don't really want that high of a number to use for something that's going to be within 0 and 33. So we'll be adding a formula to this. So let's go ahead and send this to the LCD as well. We have to figure out where we want to put this. And I know it's going to be on the second line. Let's see, where would we put? Oh, we should have put this on the second line as well. And let's see, 1, 2, 3, 4. The 4th position to the right. And we're going to make this the high trigger. And we'll do the same thing to the next case. Oh yeah, I forgot to set ADMUX to be 0x42. So now So it'll go to the next case. And let's do this to the next one as well. And we'll want this to be equal to 40 because when it's done with the last case, or the third channel, we want it to go back to the first channel, which is 0x40. And this needs to be low trigger. And we also need to change the location of the position. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it'll be 12. You know what? This, actually the high, I would say that the high should be on the left, or the right, and the low should be on the left. So let me switch that around. It makes a little bit more sense that way. So I'll make this one 12 and this one 4. So everything should be correct now. I'm going to do a make and run. Let's see, our program. Let's make. Okay, I have an error. And I forgot to put a semicolon on this line. Let's try it again. Oh, looks like there's no errors. I'm going to go ahead and program and see what we have. I noticed a couple issues. The first one being that the H and the colon was erased in the LCD, because when I was looking at when I was increasing the number, if it was 1023, it actually put spaces after and erased the H. So I'm going to modify the MrLCD.h file so it doesn't do that anymore. And what I've noticed is when I'm trying to erase the previous number, I'm actually just applying the spaces after the previous number. So what I need to do is add a go to Mr. LCD's location right here before I put the spaces in, so I can put the spaces in at the location that I'm intending to, that's brought into this this routine. And the other one is that I was only putting 1 minus the number of digits of spaces. So if I change this to 0, then I should have the correct number of digits being erased. So this is something that the library needs amendment on, and should work fine after that. I did this previously to test, and it worked fine. So back to the program. I also noticed another issue that I was not comfortable with, and this is something that we can always change in the when we're doing the actual prototype of this. Is that when I was turning the left potentiometer, I was actually affecting the high, which is on the right on the LCD, and I really don't like that. It's better to have the potentiometers in the correct location. So I'm going to make a change. Instead of high trigger being here, I'm going to have high trigger on the next one, and then low trigger can be here. So I'm essentially just swapping the low and high trigger, so it will go to the correct places. And I would also need to change these 4 and 12. So now let's determine what we need, how we need to modify this line, or what formula we need to make the limits between 0 and 34 instead of 0 and 1023. Okay, the microcontroller has been programmed, and you can see we have the raw data in the low and the high in the two potentiometers, and we have the numbers still in the inches of mercury. So everything looks like it's working fine. Obviously, these numbers won't work because they're a lot higher than what we really need. The inches of mercury will be at a maximum of 33.7, I believe it was, and the low numbers here may not even actually get into a good range. So let's see what the lowest numbers would be if we turn down the potentiometers all the way. So I'm going to turn down the first one. This is actually the high I'm turning. And I actually get a 0 on the reading. And then let's see, I'm going to turn down the low. And I also got a 0 there. I'm going to turn it all the way up, both of them. And it looks like I've got approximately 1023. So those values look like it's working well. It's going from 0 to 1023. And now we can do our formula to, we would want these as at a maximum. We'd want these at a maximum of, I would say maybe 35. So we can do our slope intercept formula to determine what formula we would need to make the high and low only go up and down from 0 to 34. It looks like I actually lost my high. So just like we did before, we'll use the slope-intercept formula, which is y is equal to mx plus b. And we'll use what I like to call the black box functions. So we have a function, and that will have x in it, which is our ADC, and that will equal what we want it to equal, which is from 0 to 34. And in the function we would have 0 here, and here we would have 1023. So to find the slope, or the coefficient m, we do this again. M is equal to rise over run, which is also equal to delta y, difference in y, the two y's, and the difference or delta in the x's. And this will be equal to, these two are the y's, and these two are the x's. So the y will be 0 minus 34, and the x's will be 0 minus 1023. Before I go on, if we had the potentiometers, so when you turn the potentiometer in one direction, it would go either down or up. If it's not going the way you want it to go, all you really need to do is swap the top number, or you can swap the bottom number. So they would be in reverse. You can say that this would be equal to, if f is 0, then you'd have this one equal to 34, and if it was at 1023, this would be equal to 0. So you can essentially reverse it without having to do that in the circuit. Either way would be fine, because you have to have a formula anyway. So let's see what our slope is. This would be negative 34, and this would be negative 1023. So let's find out what that number would be. Since we have two negatives, it's going to come out to be a positive. So this will equal 0.0332, and this will be a positive number. Now let's see what b will be equal to. And we can write down our new formula. Y is equal to 0.0332 x plus b. So let's plug in the y and x. We can use any one of these numbers. It might be easier to just use the 0. So I think we know what we're going to get. 0 is equal to 0.0332 times 0 plus b, and anything times 0 would be 0, so 0 is equal to b. So let's plug this into the program and see what we get. So our low trigger will be the 10-bit result, which is x essentially, times, we can do it like it shows on the formula, 0.0332 times the 10-bit result. We'll do the same thing to the high trigger, and we should get a more reasonable number now out of the high and low. It should be from 0 to 34. Let's test that. Let's do a make, see if I have any errors. No errors, and let's go ahead and program. So the controller has been programmed. You can see there's a much more reasonable number here. Let's go ahead and move the potentiometers and see what we get. I'm going to do the high first, which is on the right now, I hope. Yep. So we get to a 0 all the way up to, we got 33, so that's pretty close. It must not be going all the way to 1023, but it's close enough for me, so I'm going to keep it that way. I could redo the formula to achieve the 34, but I'm never going to go that high with my vacuum, so I'm not worried about it. And let me do the low. I can go to 0. And let's go all the way up to the top. See, I got 33 again, so yep, that's good. So now we have the ability to define the the high and low with a potentiometer. Let's test to see if it's working. And I'll use my own suction from my own body. Let's get something that my body will be able to produce. I can go up to about 14. Let's use some numbers that we haven't used before. I'm going to go to 9, and then this one will be maybe 3 or something. Let's go 6. Let's try 5. Alright, let's see what happens. I'm going to connect a tube to the sensor, and I'll try to put this in focus so you can see both the numbers and the LED. Okay, the LED should be in the frame. And I'm going to put the hose on and see what we get. Okay, here we go. It worked. So that is how to use more than one channel, using 3 channels and using potentiometers to affect the high and low values for the trigger, to control the LED or the pin. In the next video, I'm going to connect the relay with its own circuitry to provide the sufficient amount of current to the coil of the relay, and we'll also be prototyping this on a perf board, connecting everything together and making it more of a stable piece that I would be able to mount next to the vacuum. Thanks for watching. If you are following along with these experiments or producing successful projects on your own, helped by these tutorials, please let me know using the Contact Us page on the newbiehack.com website. I would like to feature these on the website to benefit and motivate others to join this creative field. Thank you.